Imagine Earth, billions of years ago, a time when our planet was unrecognizable, a far cry from the blue and green sphere we see today. It was a fiery ball of molten rock and metal, a seething mass of heat and energy. There were no oceans, no continents, just a searing hot surface that seemed inhospitable to any form of life. This was Earth's chaotic infancy, a time of intense heat and constant bombardment from space. Asteroids and comets relentlessly pounded the surface, adding to the chaos. The young Earth was a hostile and unforgiving place, with temperatures soaring to unimaginable heights. These extreme temperatures melted rock, sending plumes of gas and vapor into the primitive atmosphere, creating a thick, toxic haze. This was no place for life as we know it. The environment was too volatile, too extreme for any known organism to survive. Yet within this fiery chaos, the seeds of our oceans were being sown. The very elements that would one day support life were beginning to accumulate. The constant bombardment from asteroids and comets, while destructive, also brought something crucial: water. These celestial bodies carried with them ice and other volatile compounds. Locked within these celestial wanderers were ice and molecules that would eventually become the lifeblood of our planet. Each impact delivered precious water drop by drop. Over eons, these impacts deposited vast quantities of water onto the Earth's surface, gradually transforming the planet. This early period of intense heat and cosmic collisions set the stage for the remarkable transformation that would follow. The Earth was in a constant state of flux, evolving with each passing moment. Earth was about to embark on a journey of cooling and change, leading to the formation of the oceans we know and depend on today. This cooling process would take millions of years, but it was the beginning of a new era for our planet. As eons passed, the fiery wrath of early Earth began to subside. The planet, no longer subjected to constant bombardment, started to cool. This cooling was gradual but profound, transforming Earth's very essence. The molten surface, once a raging inferno, began to solidify, forming the first primitive crust. Temperatures, while still scorching by today's standards, dropped enough for gases to transition into liquids. This marked a pivotal moment in Earth's history. Among these gases was water vapor. As the planet cooled, this vapor began to condense, forming clouds in the nascent atmosphere. For the first time, Earth experienced the wonder of rain. Torrential downpours, unlike anything we see today, lashed the cooling crust. The water collected in vast depressions, forming the first puddles, then ponds, and eventually, the magnificent oceans that would come to define our planet. While cosmic impacts delivered significant amounts of water, they were not the only contributors to Earth's water supply. Earth itself played a crucial role in forming its oceans, a process that was both complex and fascinating. Deep within the planet's molten interior, a process called volcanic outgassing was underway, shaping the early atmosphere. Imagine volcanoes, not spewing lava as we often see today, but releasing massive amounts of gas, creating a thick, primordial atmosphere. This gas, a potent cocktail of water vapor, carbon dioxide, and other compounds, erupted from Earth's fiery depths, enriching the primitive atmosphere with essential elements. This outgassing, a consequence of the Earth's internal heat and geological activity, was relentless and continuous. Over millions of years, it pumped enormous volumes of water vapor into the atmosphere, contributing significantly to the growing reservoir of water that would eventually form the oceans. This process was crucial in shaping the planet's surface. This process, driven by the Earth's own internal furnace, highlights the dynamic nature of our planet, constantly evolving and changing. Earth wasn't simply a passive recipient of water from space. It actively participated in creating the conditions necessary for its oceans to form. The interplay between cosmic impacts and volcanic outgassing was vital in developing the early atmosphere and hydrosphere. As the water vapor in the atmosphere began to condense, it led to the formation of the first oceans, setting the stage for the development of life. These primordial oceans became the cradle of life, where the first simple organisms began to thrive, marking the beginning of a long evolutionary journey. While volcanic outgassing was crucial in shaping the early atmosphere and providing some of the initial water vapor, Earth also received significant help from the cosmos. Comets, those icy wanderers of the solar system, have long fascinated scientists and stargazers alike. These celestial icebergs, remnants from the solar system's formation, played a vital role in delivering water to our planet. Imagine these ancient travelers, composed of ice, dust, and rock, hurtling through the vast expanse of space. They carry within them a frozen record of the early solar system, preserving the conditions and materials from billions of years ago. As these comets collided with the early Earth, they deposited their precious cargo of ice and other volatile compounds. This extraterrestrial water, mixed with the water vapor from volcanic outgassing, significantly enriched the planet's growing hydrosphere. The evidence for this cosmic contribution comes from analyzing the isotopic composition of water. Scientists have found that the ratio of deuterium, a heavier isotope of hydrogen, to normal hydrogen in Earth's oceans closely resembles that found in comets. This isotopic similarity suggests that a significant portion of Earth's water originated from these icy messengers from the outer solar system. By studying comet samples and conducting laboratory analyses, researchers continue to uncover the mysteries of how these ancient objects contributed to the development of our planet's oceans. The story of Earth's water is a tale of both terrestrial and extraterrestrial origins, a testament to the dynamic and interconnected nature of our solar system. With the relentless rain and the combined contributions from volcanic outgassing and cometary impacts, water began to accumulate on Earth's cooling surface. At first, these were small, isolated bodies of water scattered across the primitive landscape. Over time, these bodies grew larger, merging to form vast inland seas. The planet's surface, still undergoing geological upheaval, shifted and buckled, creating depressions that filled with water. These depressions became the basins for the first true oceans. These early oceans were not the serene blue expanses we know today. They were likely murky and teeming with dissolved minerals, a far cry from the salty waters we are familiar with. Yet they represented a pivotal moment in Earth's history. The formation of oceans marked a turning point. It transformed Earth from a hot, barren world into a planet capable of supporting life. The stage was set for the next chapter in Earth's story, the emergence of life in these primordial seas. The stage was set for the next chapter in Earth's story, the emergence of life in these primordial seas. The stage was set for the next chapter in Earth's story, the emergence of life in these primordial seas.